All right, here is a video for problems 2 and 4 on our chapter 3 review. And so in problem 2 here, what we're going to do is we're going to use the fact that these shapes are similar to set up equivalent ratios and solve for a missing variable. And so in this first one here, I have to look at, okay, which sides correspond? And I see that if I kind of visualize reflecting and getting these shapes to look just like each other, I can see that 11 and x correspond. And I just need to choose one more that correspond. And I can see on this slant here, I have like 7 and 91. So I got my two corresponding sides. I should be able to set up an equivalent ratio and solve. And so what I have here is 11 over x. So what I'm doing is I'm taking the small shape divided by the big shape, corresponding sides. I'm going to set it equal to the other one. So I'm going to again start on small shape, divide by big, which will be 7 over 91. And I have my equivalent ratio. Okay. Once I have these equivalent ratios, this fraction set equal to a fraction, I'm allowed to cross multiply and then solve. So I'm going to do x times 7 is one cross multiplication and 11 times 91. Okay. Well, x times 7, that's 7x. And then 11 times 91, let me grab my calculator. And so 11 times 91, I got 1001. From here, I just need to divide both sides by 7. And if I do that, I got that x equals 143. And so I'm going to do the same kind of thing in part B here, but it gets a little trickier because I made this part B a little tougher. Okay, same kind of thing. We need to evaluate what sides are corresponding here. And this one's a little tougher to tell, but I can tell that the 63 and the 6x minus 6, those correspond because they're both the hypotenuses of these triangles. And then this one here is tough, but I can say that the 35 and the 30 are also corresponding. All right, and that takes a little bit tougher of a visualization to do. But knowing this, what I can do is I can say, okay, well, 35 divided by 30, again, dividing corresponding sides. This time I'm doing the big triangle divided by the little, and I'm going to set that equal to 63 divided by 6x minus 6. And we can see this here. I'm dividing corresponding sides, 35 from the big, 30 from the small. Staying consistent, 63 from the big divided by 6x minus 6 from the small. Okay? Well, now I need to cross multiply and solve again. So 30 times 63 and 35 times 6x minus 6. Well, 30 times 63 gives me 1,890. Equal sign stays. And then I'm not actually even going to do this multiplication. I'm going to say this is 35 times this piece here, 6x minus 6. Didn't even do the multiplication there because I don't want to. Okay? Now we just have a series of events to get x by itself. So the first thing I'm going to do is, not that, I'm going to divide both sides by 35 so that these 35s go away. All right, so then I got 1890 divided by 35. After I do that, I'm left with 54. So 54 equals 6x minus 6. I'm going to add 6 to both sides. So I have 60 equals 6x. And then lastly, I just need to divide by 6. And I'm going to end up with x equals 10. So definitely a tougher problem there. But the big thing is being able to set up the correct equivalent ratio and then being able to do the division and everything from here. So there's this problem for 2b. If you want, another explanation of it, a different way to go about it, that way didn't make sense, let me know. I can try to do something else. Okay. Now let's take a look at 4. So in this one, we are told that BC, B prime, C prime is parallel to BC, very helpful. And we're going to use this fact to answer the following questions. Okay. So we want to know how ABC or AB prime C prime is similar to ABC. Well, if I have parallel lines like I do here, BC and BC, then AB here is a transversal cutting those parallel lines. So we're allowed to say, well, when a transversal cuts parallel lines, the corresponding angles here are congruent. And so we have a pair of congruent angles there. And not only that, both of these triangles, A, B prime, C prime, and ABC, they both share angle A. And so these triangles are similar. They are similar because they have angle similarity. Because these corresponding angles and that they share angle A. Okay? Now that we know that these triangles are similar, we can use the zoom factor or equivalent ratios to solve for x. And what I have here is I have this full side length here, A to B, that equals 10. And I can draw this out too. I could make a triangle A, B prime, C prime. And we know that the small triangle has 4 and x, so 4x. And then we have a bigger triangle, ABC, that had, well, 4 and 6 combined, that gives me a length of 10. X and 9 combined, that gives me a length of 9 plus x, and it becomes a problem like we just solved in 2b. All right? What we need to do, we can set up an equivalent ratio here. I can do 10 divided by 4 equals 9 plus x over x. Right? Because I'm taking corresponding sides here, 10 and 4, and dividing it big by small. And the same thing with 9 plus x and x. If I start doing my cross multiplication here, I get 10x equals 4 times 9 plus x. This time I need to distribute my 4 in to both. So this is 10x equals 36 plus 4x. I can subtract 4x on both sides to try to move them all onto one side here. And I get 6x equals 36. When I divide both sides by 6, I end up with x equals 6, because 36 divided by 6 gives me 6. Okay? Lastly, and nice and shortly, we have to write our similarity statement, and what we can say is, we could say triangle, and I'll write it out in a little bit nicer way here. Triangle A, B prime, C prime is similar to triangle A, B, C, and make sure our vertices are aligned in the correct way. So if I go A, B prime, C prime, A, B, C is the same order, same pattern, and so this is the correct way to write it. Okay, those are the tougher problems, and the last one's pretty tough too. Let me know how this explanation works for you. Let me know if it helps, and let me know if there's anything else I can help you with.